Hello there and welcome to the sleepy universe. Tonight we turn our eyes toward the nearest light in the dark sky above us. The moon, quiet and constant, the same gentle companion that has watched over every night of human history. We will drift together through 100 calm facts about this pale, patient world. The silver light it lays across still water, the wide, dark seas of ancient stone that were never seas of water at all, and the soft-edged craters that have kept their shape for longer than any mountain range on Earth. We will follow the slow pull of its gravity through the tides, feel the quiet rhythm of its phases turning night after night, and trace the careful journeys that once carried human footprints across its dust. There is nothing to solve tonight, and nowhere you need to be. Let your shoulders soften into the mattress, let your breath grow long and unhurried, and let the moon steady, silver quiet carry your thoughts gently away until sleep finds you on its own. Among everything that circles our planet, one companion stands apart from the rest. The moon, Earth's only natural satellite, and the closest large body in our sky. Where planets are distant points of light and stars are impossibly far suns, the moon is close enough to show us mountains, plains, and shadows, with nothing more than patient eyes turned upward. It has traveled beside Earth for billions of years, bound to us by gravity, never wandering off into its own solitary path the way a comet might. Every civilization that ever looked up found it already there, calm and unhurried, tracing its quiet arc through the dark. Nothing else in our sky offers that same steady nearness. The planets rise and set too, but they remain small and faint in comparison. The moon, by contrast, is generous with its presence, large enough to show detail, bright enough to cast shadows at night, close enough to feel like a neighbor rather than a stranger. That closeness is why it has shaped so much of how humans experience the night, offering a fixed point of gentle light in an otherwise scattered sky, a companion that asks for nothing but a little attention. Held up against the sky, the moon looks impressively large to our eyes, yet its actual share of the heavens is modest and precise. About half of 1 degree, roughly the width of a fingertip held at arm's length. Astronomers describe this as its angular size, a way of measuring how much space an object seems to take up in our field of view rather than its true size. What makes this number remarkable is that the sun, despite being about 400 times wider than the moon, also happens to sit about 400 times farther away, so it occupies almost exactly the same half-degree slice of sky. Two objects of such different scale, ending up looking nearly identical in size from where we stand, is one of those gentle coincidences the universe seems to offer now and then. It is this near-perfect match that allows the moon to occasionally align with the sun in a way that produces the soft, dark spectacle of an eclipse, a subject the sky saves for its own quiet chapter later on. For now, it is enough to simply notice the coincidence itself, resting there above us, unremarked upon by most, yet strangely precise. Every soft glow the moon sends down to us at night is simply borrowed light, sunlight striking its surface and bouncing back across the 250,000 miles of space between us. The moon has no glow of its own. In the blackness of space, it would be entirely invisible without the sun to illuminate it, the same way a mirror stays dark in an unlit room. What might surprise a sleepy observer is that the moon's surface is not especially reflective at all. Measured by scientists as albedo, the fraction of sunlight a surface bounces back. The moon reflects only about 12% of the light that reaches it, making its ground roughly as dark as worn asphalt or a piece of charcoal. Against the deep black of space, however, even that small fraction of reflected light is enough to appear brilliant to our eyes, since nothing nearby competes with it. Our eyes are drawn to contrast rather than true brightness, so a dim gray surface set against total darkness reads as luminous and silver. The moon is modest in what it actually reflects, generous only in comparison to the emptiness that surrounds it, borrowing just enough daylight to light our way home. On average, the moon rests about 238,000 miles from Earth, or roughly 384,000 kilometers, a distance that changes gently as it travels its slightly oval path around us. Numbers this large can be hard to hold in mind, so it helps to picture them slowly. If every planet in our solar system were lined up in a row, from tiny Mercury to giant Neptune, all of them together could almost be tucked into the space between Earth and the moon, with a little room left to spare. Light itself, the fastest thing there is, takes about 1.25 seconds to cross that same gap. So when moonlight reaches our eyes, we are seeing it almost as it left, a brief, gentle delay rather than the years it takes starlight to arrive. Commercial airplanes, which feel fast when we are inside them, would need roughly 3 weeks of steady, non-stop flying to cover that same distance. And yet, on the scale of the universe, this gap is nearly nothing, a short hop compared to the vast emptiness beyond it. The moon, in truth, is remarkably close, our nearest companion in a sky otherwise built from unimaginable distances. Contrary to what a tired mind might assume, the moon does not belong only to the night. On many afternoons, if you look up at the right moment, you can find it hanging quietly in a blue sky, pale and half-transparent against the daylight, easy to miss unless you already know where to search. Whether the moon appears during the day or only after sunset depends on where it happens to be in its slow monthly journey around Earth relative to the sun. Near the full moon, it rises around sunset and sets around sunrise, keeping mostly to the night. But in its other phases, its schedule shifts gradually, rising and setting earlier or later each day, which means for roughly half of any given month, part of its path crosses through daylight hours as well. A first quarter moon, for instance, often sits high in the afternoon sky long before evening arrives. There is something quietly comforting in this fact, a reminder that the moon is always there, tracing its path whether the sky around it happens to be bright or dark. We only notice it more at night because the darkness lets its soft light stand out against a calmer, dimmer backdrop. Anyone who has watched a full moon rise has likely noticed a strange and pleasant trick. Low on the horizon, the moon can look enormous, swollen, almost close enough to touch, while later, high overhead, that same moon seems to shrink back down to its ordinary size. This is known as the moon illusion, and despite centuries of observation, it remains one of the sky's gentler mysteries. What matters most is what it is not. The moon itself has not changed size or moved closer to Earth in those few hours. A photograph of the horizon moon and the overhead moon, measured carefully, shows the two are almost exactly the same size. The difference exists only in the mind. One gentle explanation researchers offer is that our brains judge size by comparison, and near the horizon the moon sits close to trees, rooftops, and distant hills, familiar objects that trick our sense of scale into reading it as larger. Overhead, with only empty sky around it, that same moon has nothing to be measured against, so it appears smaller. It is a soft reminder that even something as steady as the moon can be reshaped by the quiet, imaginative habits of human perception. There is a quiet kind of loyalty built into the moon's motion. It always shows Earth the very same face, night after night, century after century, never turning to reveal what lies around back. This happens because the moon rotates on its own axis in almost exactly the same time it takes to orbit Earth, a gentle balance called tidal locking. Long ago in the moon's early history, Earth's gravity worked slowly on its shape, stretching it just slightly and creating a faint bulge. And as the moon rotated, that bulge acted like a soft brake, gradually slowing its spin until the two rhythms, its turning and its orbiting, settled into perfect agreement. Once that balance was reached, it stayed that way, locked into place the way a slow dance settles into a single repeating pattern. The result is a moon that keeps one face turned toward us always, familiar and unchanging, while its other side faces the endless dark beyond. This is not something dramatic or sudden. It is the outcome of countless slow adjustments across enormous stretches of time until stillness and balance won. It is a fitting kind of steadiness for an object so often associated with calm, patient rhythm. Watch the moon patiently across a single night, and you may notice it is not fixed in place the way distant stars seem to be. It drifts, slowly and steadily, eastward against the background of the stars themselves. This happens because the moon is slowly orbiting Earth even as Earth itself turns. So on top of the nightly westward sweep every star and planet appears to make, the moon adds its own gentle motion in the opposite direction. Over the course of one night, it shifts noticeably compared to the stars around it, and from one evening to the next, it rises about 50 minutes later each time, gradually working its way around the entire sky over roughly a month. Someone who watches the sky over several nights in a row can catch the moon sliding past the same bright stars it sat beside the evening before, a slow and patient game of leapfrog played out above our heads. There is no rush to any of it. The motion is smooth, unhurried, and predictable, the kind of quiet, dependable drift that has let careful sky watchers, across thousands of years, use the moon like a slow-moving hand on a very old, patient clock. A full moon rising near the horizon often wears a color it does not carry once it climbs higher into the sky. A soft orange, a warm gold, sometimes even a gentle red, rather than the pale white or silver we associate with moonlight overhead. The reason has nothing to do with the moon itself, which has not changed at all, but with the thick slice of Earth's atmosphere that moonlight must pass through when the moon sits low. Near the horizon, light travels a much longer path through the air than it does when the moon is directly overhead, passing through far more dust, moisture, and countless tiny molecules along the way. That longer journey scatters away much of the shorter, bluer wavelengths of light, leaving mostly the longer, warmer wavelengths, the oranges and reds, to reach our eyes. It is the very same gentle process that paints sunsets in those familiar warm colors each evening. As the moon climbs higher, its light has less atmosphere to cross, the warmer tones fade, and it settles back into its familiar pale glow. So that low, golden moon on the horizon is simply ordinary moonlight, filtered softly and beautifully by the same sky we breathe. The moon's path around Earth is not a perfect circle, but a gentle oval, which means its distance from us changes throughout each month, drawing slightly closer at one point and drifting slightly farther at another. When a full moon happens to align with the point in its orbit where it sits closest to Earth, called perigee, The result is what many now call a supermoon, a moon that appears a little larger and a little brighter than an ordinary full moon. The difference is real but modest, nothing dramatic or startling. A supermoon can appear roughly 14% larger and about 30% brighter than the smallest full moon of the year, a change most people would never notice without a careful side-by-side comparison. Still, there is something quietly pleasing about knowing the exact night the moon sits closest, an invitation simply to look up. The term itself is a modern one, born from popular astronomy rather than formal science. But the gentle rhythm behind it, the slow drawing near and drifting away, has been part of the moon's quiet orbit since long before anyone thought to name it. Long ago, in the quiet dark of the early solar system, our little Earth was still new, still settling, still cooling from its own formation. Astronomers believe that during this early time, a body roughly the size of Mars drifted across the same stretch of space, and ever so slowly on a cosmic scale, came into Earth's path. This is called the giant impact hypothesis, and it remains the leading explanation for how the moon came to be. Rather than picture anything violent, it helps to imagine a slow, distant meeting between two young worlds, unfolding over hours and days rather than an instant. In the aftermath, a great deal of material was lifted into orbit around Earth, forming a wide, faint ring of dust and rock, glowing softly in reflected sunlight. Over time, this ring drew itself together, grain by grain, fragment by fragment, in the patient way that gravity always works. What had once been scattered debris slowly gathered into a single round companion, settling into a smooth and steady orbit. It is a gentle thought that the moon above us tonight began as leftover light and dust, quietly assembling itself in the dark, long before the first shoreline on Earth. By the careful reckoning of scientists who study rock and time, the moon is thought to be about 4.5 billion years old, which makes it almost as old as Earth itself, born within perhaps only 100 million years of our own planet's earliest days. That may sound like an impossibly long stretch, but it helps to think of it simply as very early, near the beginning of the solar system's quiet story, when the sun itself was still young and the planets were only just settling into place. Scientists have learned this age patiently, by studying small samples of moon rock brought back to Earth and measuring the gentle decay of certain elements locked inside them, a kind of natural clock ticking silently within the stone. Each measurement taken softly in a laboratory agrees with the others, pointing again and again to that same ancient number. So when we look up at the moon tonight, we are looking at something almost as old as time itself feels to us, a companion that has quietly kept pace with Earth through nearly the whole history of our world, from its molten beginnings to this calm night. Early in its story, the newly formed moon is thought to have circled much closer to Earth than it does today, drifting along an orbit only a small fraction of the distance we know now. Astronomers who study orbits believe that, seen from Earth in those ancient nights, the moon would have appeared strikingly large in the sky, filling far more of the view than the gentle disk we watch rise this evening. Imagine, if it helps you rest, a vast pale shape hanging low and close, its soft light spreading wide over young oceans that had no shore yet worth naming. There would have been no one to see it, no eyes yet open to that early sky, but the light was there all the same, falling gently across a world still finding its shape. Little by little, over countless slow turns of time, the moon began the long, unhurried journey outward that continues even now, moving away from Earth by a small amount each year. That early closeness is simply one more quiet chapter in a story of gradual drifting, a reminder that even something as steady as the moon has always been slowly, gently on the move. For a long stretch after it first came together, the young moon is thought to have been anything but the cool, still place we picture today. Astronomers believe its outer layers were likely molten, a wide and glowing ocean of liquid rock stretching across much of its surface, warmed by the energy of its own formation and by the slow settling of material within. It can help at bedtime to picture this simply as a long season of gentle heat, a world wrapped in soft, dim light of its own making rather than borrowed from the sun. Over a long stretch of time, immense by any human measure, that molten surface began to lose its warmth to the cold quiet of space around it, cooling slowly, the way a warm stone left out at night slowly gives up its heat to the dark. As it cooled, the once liquid rock gradually settled and thickened, the whole surface calming into something firmer and more still. This slow cooling was one of the moon's first quiet transformations, a long, unhurried passage from a glowing young world into the pale, settled companion that would eventually hang steady and calm above our own quiet nights. As that early molten surface of the moon slowly gave up its heat, something quiet and orderly began to happen within it. Heavier minerals, astronomers believe, gradually sank toward the interior, while lighter minerals drifted upward, rising gently through the cooling rock the way cream slowly rises in a still glass of milk. Over a long, unhurried stretch of time, this rising material gathered near the surface and hardened, forming a pale, light-colored rock called anorthosite, which became much of the moon's earliest crust. This is part of why certain regions of the moon's surface appear so pale and bright to us even now, catching sunlight in a soft, silvery glow rather than a deep gray. It is a gentle image to hold in mind, a small world sorting itself quietly by weight and light, layer settling upon layer in complete silence, with no wind and no sound to mark the change. The cooling and settling happened across many millions of years, patient beyond ordinary imagining, until a solid shell had finally formed around the moon. That early crust, born from slow cooling and quiet rising, became the first firm ground of the world we still watch drifting calmly overhead tonight. One of the quiet clues that supports the giant impact idea comes not from watching the sky, but from careful study of rock itself at the smallest scale. Scientists have compared the isotopes, tiny variations of the same elements, found in moon rocks with those found in rocks from Earth, and have discovered that the two match one another remarkably closely, far more closely than we might expect if the moon had simply formed elsewhere and wandered into Earth's orbit. This close resemblance suggests, gently, that Earth and the moon share a common origin, that much of the material now making up the moon may once have been part of our own young planet, or of the same swirling neighborhood of dust nearby. It is a quiet kind of kinship, written not in appearance but in atoms, patient enough to be read only in careful laboratory measurements long after the fact. Researchers continue to study these small differences, refining their understanding a little at a time, the way any patient study unfolds. But the pattern remains steady. Earth and moon, so different to look at, so alike in their most basic ingredients, like two candles lit long ago from the very same quiet flame. Deep beneath its calm gray surface, the moon holds a small core, modest in size when set beside the great metallic heart at the center of Earth. Where our planet carries a large core of iron and nickel, one that makes up a substantial share of Earth's whole mass, The moon's core is thought to be quite small by comparison, a minor part of the whole quiet body above it. Earth's core fills roughly half of our planet's width, while the moon's core fills only a slim fraction of its own, a modest seed of metal near its center. Astronomers believe this difference in size fits gently with the giant impact idea, since much of the iron-rich material from the young, forming Earth is thought to have stayed behind in our own core, while the moon gathered together from lighter, outer material flung into orbit, material that never carried much of that dense metal to begin with. It is worth pausing on this quiet contrast. Two neighbors, formed from much of the same material, and yet one carries a vast metal heart while the other holds only a quiet, unassuming center of its own, each shaped long ago by how it came to be. After its earliest years of forming and cooling, the young moon is thought to have passed through a long period, when it was struck more often by wandering rocks and debris still drifting through the young solar system. Astronomers sometimes call this the era of heavy bombardment, though it helps to picture it not as anything sudden, but simply as a slow, scattered rain falling across a very long stretch of time, far beyond any single human lifetime. Earth almost certainly experienced this same gentle rain, but our planet's wind, water, and shifting ground have long since smoothed and softened almost every trace of it. The moon, with no wind of its own to erase anything, simply kept its record, holding each small arrival quietly on its surface across the ages. Little by little, as the young solar system settled and tidied itself, this period slowed and eventually faded into calm, leaving the moon to rest undisturbed. It is enough for tonight to hold this simply as one more chapter in a very old story. A distant, quiet season, the moon passed through long before it settled into the still and steady companion we watch drifting peacefully above us now. Among the many quiet things the moon does for Earth, one has nothing to do with light or tides, but with steadiness itself, carried with it from its very first days beside our planet. Earth spins on a gently tilted axis, leaning at an angle as it turns through space, and that lean has stayed remarkably constant across an immense stretch of time. Scientists believe that the moon's steady gravity, pulling gently on Earth over billions of years since their shared beginning, helps hold that tilt within a narrow, comfortable range, keeping it from wandering too far in one direction as the ages pass. Without a companion of the moon's size formed so early nearby, some researchers think Earth's axis might drift and wobble far more freely over long stretches of time. So in a slow, invisible fashion, the moon has acted almost like a steadying hand resting quietly on Earth's shoulder ever since those early days, holding our world gently upright as both spin together through the dark. We rarely think of the moon this way, as a keeper of balance rather than a lantern in the sky, but the two roles have been joined together since the very beginning. Across its long early history, the moon moved slowly from a warm, partly molten world toward the cool, quiet companion we know tonight. Its once glowing surface hardened first, but far beneath that new crust, deeper layers continued cooling for a much longer time, releasing warmth gradually out into the dark of space across many hundreds of millions of years. Even the scattered heat of early impacts and the last slow stirrings within its interior faded gently with time, like the last embers of a fire settling quietly long after the flames have gone. Little by little, the moon grew still, its inner motions slowing, its brief activity giving way to a long, steady quiet that has lasted for billions of years. What we see above us tonight is the result of that ancient settling, a world that finished its restless youth long long ago, and has rested in calm silence ever since. It is a gentle thing to consider before sleep, that the steady, unchanging companion in our sky was not always so quiet, but slowly, patiently cooled and settled into the peaceful stillness it has now kept faithfully for so very long. Across the near side of the moon lie wide, dark, flat regions that early skywatchers named seas, though not one drop of water has ever touched them. In Latin, these plains are called Maria, and a single one is a mare, a word chosen long ago by astronomers imagining dark oceans spread across some distant, quiet shore. In truth, these smooth plains are ancient lava, poured out long ago when the moon's interior still held pockets of deep warmth, and the crust briefly opened to let that dark, molten rock flow wide and settle into low basins carved by earlier, gentler collisions. Slowly across vast stretches of time, the lava cooled and hardened into basalt, a dense volcanic stone that appears darker than the paler, older highlands surrounding it. That soft contrast is what human eyes have always noticed from below, the quiet gray patches forming shapes that different cultures once read as a face, or a rabbit, or a woman bent over reading. Tonight, as gentle moonlight settles over you, remember that its darker patches are simply cooled stone, holding centuries of stillness. A soft reminder that even old fire, given enough patient time, can settle into something calm and restful. Scattered across the moon's entire surface, in numbers far beyond counting, lie craters of every size, from small dimples no wider than a garden to broad, round basins that stretch for many miles. Long ago, in the quiet dark of the solar system's early years, small bodies drifted through space and settled gently onto the moon, leaving their round marks behind like footprints pressed into soft ground. On Earth, such marks rarely last, since wind carries dust across them, rain softens their edges, and slow-growing rivers and forests quietly erase what time has written. The moon knows no such changes. Without air to carry wind, without clouds to hold rain, and without living roots to stir the ground, each crater rests exactly as it was formed, undisturbed for thousands, even millions of years. Some craters are shallow, worn faint by countless smaller impacts, while others still show crisp, rounded walls as if shaped only yesterday. Astronomers read these overlapping circles the way one might read rings inside an old tree, each one a quiet record of time passing. Looking up tonight, you are seeing a surface where nothing is smoothed away, only softly lit, patient and unchanged, holding its whole history in silence. Near the moon's southern highlands sits a crater named Tycho, honoring a careful Danish astronomer who studied the sky centuries ago, long before telescopes existed. Tycho is not the largest crater on the moon, but it may be among the easiest to notice, especially around the time of the full moon, when its long, pale rays stretch outward across the surface like the spokes of some enormous wheel. These rays formed in a single, distant moment, when whatever struck the moon threw fine, bright material outward across hundreds of miles, scattering pale dust and shattered rock over the older, darker ground nearby. Because that material is younger and less worn by time than the surface around it, it reflects sunlight more brightly, so the rays appear pale and luminous rather than blending quietly into the landscape. Over countless years to come, slow processes will gently darken these rays, softening them until they fade into the surrounding ground, much as bright things eventually settle into stillness. For now, though, if you look toward a full moon, you may be able to trace Tycho's soft rays reaching outward, a quiet fan of light resting on ancient, patient stone, visible from 250,000 miles away. Rising gently along the edges of some of the Moon's oldest impact basins are long mountain ranges, among them the Montes Apenninus, named long ago after the Apennine Range that runs down the length of Italy. These lunar mountains are not the product of shifting plates or slow-building pressure the way many of Earth's mountains are, since the Moon has no moving plates beneath its surface. Instead, they rose in a single, sudden lift long ago, when a large body settled into the Moon, pushing the surrounding ground upward and outward in an uneven ring, the way ripples might lift the edges of a still pond, though frozen here in solid stone rather than water. The Apennines curve for hundreds of miles along the border of the basin, now called the Sea of Rains, their peaks catching low sunlight at dawn and dusk, when long shadows stretch gently across the plains below and reveal their height and shape most clearly. Some of these peaks rise higher than many mountains found on Earth, yet without wind or rain to shape them further. They have kept their ancient outlines for billions of quiet years, standing as calm, motionless witnesses along the rim of that old, wide basin. Covering nearly the entire surface of the Moon is a fine, powdery layer called regolith, a soft blanket of dust and broken rock that has gathered slowly over billions of quiet years. Unlike soil on Earth, which forms partly through rain, rivers, wind, and living roots pressing through the ground, lunar regolith formed almost entirely through countless small impacts, as tiny fragments from space struck the surface again and again, slowly crushing solid rock into smaller and smaller pieces. Over vast stretches of time, this gentle grinding produced a layer that in some places reaches only a few inches deep, and in others stretches down many feet, resting quietly atop the harder rock below. Regolith is unusually fine, almost like flour or powdered chalk, yet its edges remain sharp and jagged under close inspection, since there is no wind or water on the Moon to soften or round them, the way flowing rivers smooth stones on Earth. When sunlight falls across it at a low angle, this soft powder can seem to glow gently, holding the light rather than scattering it away. It settles into every hollow and slope, a quiet, patient cushion laid gently across the whole of the Moon's silent, sleeping ground. Because the Moon always shows Earth the same familiar face, a second, hidden half turns quietly away on what is called the far side, unseen from Earth throughout human history. That hidden half looks quite different from the face we know so well. Where the near side carries wide, dark maria spread gently across its surface, the far side shows far fewer of these smooth, dark plains, and instead is covered almost entirely by pale, ancient highlands crowded closely with craters overlapping craters. Astronomers believe this difference has to do with the far side's slightly thicker crust, which likely made it harder for deep, molten rock to rise and spread across the surface the way it did on the thinner near side long ago. The far side remained a complete mystery for centuries, hidden from every human eye, until the middle of the 20th century, when a spacecraft first sent back faint, grainy images of its rugged, crowded landscape, revealing a face humanity had never once seen with its own eyes. Even now, it turns gently through darkness and light, unseen from any window on Earth, holding its quiet, ancient story just out of sight. Along the Moon's far side, stretching across part of its southern region, lies one of the largest known impact basins in the solar system, a vast, ancient scar called the South Pole Aitken Basin. It reaches across thousands of miles, wide enough to hold entire countries within its gentle, sunken outline, and reaches down several miles deeper than the ground surrounding it. Astronomers believe it formed early in the moon's history, when a large body drifted quietly through the dark and settled against the surface, releasing tremendous energy that pressed deep into the crust, and some researchers think may have thinned it dramatically across that one wide region. Unlike the smooth, dark Maria found on the near side, this enormous basin was never filled by rising lava, so it appears rugged and pale, crowded with smaller craters that have gathered slowly across its floor over billions of years. Because of its depth, scientists studying the moon consider this basin a gentle window into deeper layers rarely exposed elsewhere, a place where ancient material may rest closer to the surface than almost anywhere else. Hidden from Earth entirely, facing only empty space, it remains one of the quietest, least seen places across the whole of the moon. Long before anyone understood what the moon's dark plains were made of, early astronomers looked upon them through simple telescopes and gave them names filled with quiet feeling, as though describing a distant, peaceful world. They called one expanse the Sea of Tranquility and another the Sea of Serenity, names that carry a soft, calming weight centuries later. Nearby lie the Sea of Nectar, the Sea of Clouds, and the Sea of Rains, each name chosen not from careful measurement but from a gentle impression, a feeling that these dark regions resembled still water beneath a calm sky. Even smaller features received tender names to match, such as the Marsh of Sleep and the Lake of Dreams, quiet plains resting near the larger seas, as if the whole near side had been mapped by someone imagining a peaceful evening rather than measuring a distant world. These names have endured for centuries, long after astronomers understood that no water ever filled them, because they still capture something true about how the moon feels to a quiet observer below. Tonight, somewhere above you, tranquility and serenity rest side by side upon that pale surface, two of the gentlest names given to any place beyond the earth. Winding gently across parts of the moon's surface are long, narrow valleys called rills, channels that curve and bend for many miles like quiet rivers traced onto pale stone. Some rills run in fairly straight lines, following old cracks in the crust, while others twist and curve gracefully, doubling back on themselves in soft, wandering paths that early observers found difficult to explain. Astronomers now believe most winding rills are the remains of ancient lava channels or collapsed lava tubes, formed long ago when molten rock flowed swiftly across the surface, sometimes cutting a shallow trench as it moved, and sometimes flowing hidden beneath a hardened roof that later fell in upon itself, leaving a long, open groove behind. One of the best-known examples, Hadley Rill, winds near the foot of the lunar Apennine Mountains, and was studied closely by astronauts who once stood quietly at its edge, looking down into a valley shaped by fire long before human eyes ever existed to see it. From above, these rills look almost like dry riverbeds, gentle and meandering, though no drop of water carved them. They remain frozen in place exactly as they cooled, soft gray lines resting across the moon's calm, ancient, unchanging face. With no blanket of air surrounding it, the moon's surface experiences some of the most extreme temperature swings known nearby in space. During the long lunar day, which stretches for roughly 2 Earth weeks, sunlight beats directly onto the open ground with nothing to soften or scatter it, and surface temperatures can climb to levels hotter than boiling water, especially across the pale, dusty plains and exposed rock. Then, as the long lunar night slowly arrives, also lasting about 2 Earth weeks, that same ground loses its heat rapidly into the surrounding darkness, since there is no atmosphere to hold warmth close to the surface the way Earth's air gently does for us each night. Temperatures then fall to levels far colder than any winter known on Earth, turning the once sunlit ground into a silent, deeply frozen landscape. This shift happens gradually, not suddenly, since the moon turns slowly on its axis, giving its surface time to warm and cool in long, unhurried stretches. Heat and cold follow one another in this same patient turn, night after night, the ground blazing and then resting into stillness beneath the silent, watching stars. Far out in the quiet dark, the moon's gentle gravity reaches down across 238,000 miles and rests its hand upon the surface of the sea. Water, being fluid and free to move, answers that pull more readily than solid rock, and so a slow bulge of ocean rises on the side of Earth that faces the moon. At the very same time, a second gentle bulge forms on the opposite side of the planet, because the moon pulls a little less strongly on the far side than it does on Earth's center, leaving that distant water slightly behind. As our planet turns on its axis through the day and night, continents and coastlines pass beneath these two slow mounds of water, and that passage is felt on shore as the tide rising and falling. Most coastlines therefore drift through two high tides and two low tides in about 24 hours and 50 minutes, a rhythm as steady as breathing. It is a strange and lovely thought that something so far away and so quiet can reach into the ocean and lift it, ever so gently, twice each day, in a motion too slow for any single wave to show. The moon is not the only body reaching for Earth's oceans. The sun, though far more distant than the moon, is also vastly larger, and even across 93 million miles it still manages to tug gently at our seas. Because it is so far away, the sun's pull on the tides is gentler than the moon's, working out to less than half its strength, a quiet second hand resting alongside the first. On its own, the sun could never lift the oceans as the moon does, but it does not act alone. Depending on where it stands in the sky relative to the moon, the sun's pull can either lean into the moon's pull, making the tides a touch higher and lower than usual, or lean gently against it, softening the difference between high water and low. Neither push is dramatic. Both unfold over hours, felt only in the slow creep of the waterline up a beach or the quiet retreat of a tide pool. Astronomers think of the ocean as answering two patient partners at once, the moon close and strong, the sun distant and soft, their combined pull shaping the rise and fall of every shoreline day after day, season after season. Twice in every lunar month, the sun and moon line up with Earth, whether the moon sits between Earth and sun at the new moon, or Earth sits between them at the full moon. In either case, the pull of the sun adds itself to the pull of the moon, and the ocean answers with a slightly higher high tide and a slightly lower low tide than usual. These are called spring tides, a name that has nothing to do with the season and everything to do with an old word meaning to leap or well up, since the water seems to spring a little higher along the shore. About a week later, when the moon has moved a quarter of the way around its orbit and stands at a right angle to the sun, the two pulls work against each other, and the difference between high and low tide softens into something gentler. These quieter tides are called neap tides, returning every month like a soft exhale between the fuller breaths of the spring tides. Together, the two patterns weave a slow, fortnightly rhythm into the sea, one that has rocked every shoreline since long before anyone gave it a name. Because Earth spins so much faster than the moon orbits, the ocean's tidal bulge is not left to sit quietly beneath the moon. Earth's rotation drags that bulge slightly ahead, faster than the moon can follow. This means the heavy mass of moving water sits just ahead of the moon in its orbit rather than directly beneath it, and that small offset gives the bulge a gentle gravitational hold on the moon, tugging it forward along its path. A steady forward tug on an orbiting body does not pull it closer, but nudges it into a slightly wider orbit, and so, fact by patient fact, the moon is spiraling away from Earth, drifting outward by about 1.5 inches, or roughly 4 centimeters, every single year. It sounds small, and on any human timescale it is small, less than the width of a fingernail's growth. But across the deep span of geological time, that quiet drift adds up, and scientists can measure it with remarkable precision. In the distant future, this slow retreat means the moon will sit farther out and shine with a slightly gentler light, the change silent, unhurried, and always on the move. The same gentle friction that pushes the moon a little farther from Earth each year also reaches back and touches Earth itself, slowing its spin by the smallest imaginable amount. As the tidal bulge drags very slightly ahead of the moon, it acts like a soft brake on our planet's rotation, and Earth's turning gradually loses a little of its speed. The effect is far too small to notice in any single lifetime, adding only about 2 milliseconds, a tiny fraction of a heartbeat to the length of a day every 100 years. Still, scientists who study ancient coral and the fine growth lines left in old seafloor sediment have found evidence that, hundreds of millions of years ago, a full day on Earth lasted only about 22 hours instead of 24, meaning a year once held more, shorter days. Looking forward, the same slow arithmetic suggests that far off in the future, a single day on Earth will stretch out longer than it is now, minute by unhurried minute. It is a strange kind of patience to imagine, a planet's spin easing over millions of years because a quiet moon, far off in the dark, keeps a gentle hand upon the sea. Along certain coastlines, the twice-daily rhythm of the tides grows far more dramatic than elsewhere, and nowhere more so than the Bay of Fundy, resting between Nova Scotia and New Brunswick on Canada's Atlantic coast. There, the difference between low tide and high tide can reach as much as 50 feet, more than the height of a 4-story building, making it the largest tidal range found anywhere on Earth. This happens not because the moon pulls harder on that one bay, but because of its long, narrowing shape, which happens to match the natural rhythm of the incoming tide. So each new surge builds upon the one before it, the way a timed push builds height on a swing. Twice a day, enormous volumes of water slide in and then withdraw, uncovering wide stretches of red-brown mudflats before quietly returning to cover them again. Other shorelines around the world, like parts of the Bristol Channel in England, share something of this same grand rhythm, though none quite match Fundy's scale. Standing at the edge of such a bay at low tide, looking over the great empty basin soon to be filled again, is to witness one of the ocean's most patient acts of breathing. Between the line the water reaches at high tide and the line it retreats to at low tide lies a narrow strip of shore that leads 2 entirely different lives within a single day. For a few hours it rests fully underwater, gentle waves moving over rock and sand, and then, as the tide withdraws, that same strip lies open to the air, drying slowly before the sea returns to cover it once more. This rhythm of exposure and return shapes the shoreline itself, smoothing stones, carving small tidal pools into rock hollows, and sorting sand and gravel into patterns that shift with each cycle. Salt marshes and mudflats form in the quieter reaches of this zone, where the twice-daily flooding brings in fine sediment and carries away what the land no longer needs, feeding a long, patient food chain. Along rockier shores, the same rhythm carves tide pools that hold their own small, still worlds for a few hours at a time, warmed by the sun until the sea slides back in to refresh them. It is a border built entirely by the moon's patient pull, redrawn twice a day, and the coastline over centuries quietly bears the shape of that repeated, gentle motion. It is easy to think of the tides as something that belongs only to the ocean, but the moon's gentle pull does not stop at the water's edge. The solid ground beneath our feet, the very rock and soil that feels so fixed and permanent, rises and falls too, in a motion so small that no person has ever felt it. Scientists call this an earth tide, and it moves the surface of continents up and down by several inches, roughly the height of a shoebox, twice within each day, echoing the same quiet rhythm as the sea. Solid rock seems perfectly rigid to us, yet across the true scale of a planet, stone behaves a little like a very stiff, very patient kind of dough, flexing under a pull too gentle for muscle or bone to ever sense. Instruments built with extraordinary sensitivity, used in some of the most careful scientific experiments on Earth, can detect this rise and fall and must be calibrated around it. There is something quietly wondrous in the idea that the whole solid Earth breathes along with the sea, lifted and lowered by the same distant moon, in a motion too slow and too small for anyone to notice. Among the countless creatures that live in the sea, some seem to carry a quiet awareness of the moon's phase, timing important moments of their lives to its slow cycle rather than to the calendar or the season alone. Coral is one of the gentlest examples of this. On many reefs once a year, coral colonies that sit still and silent for months release eggs and sperm into the water within the very same narrow window, often just a few nights after a full moon, when the night sky carries its fullest light. Millions of tiny pale bundles drift upward together through the dark water, an event so synchronized across a reef that it can look, for a few hours, like a slow, silent snowfall happening underwater instead of in the sky. Scientists believe moonlight may act as a kind of quiet signal here, a shared cue visible to every coral polyp at once, helping so many separate, unmoving creatures act together on the very same night. It is only one small example of how deeply the moon's rhythm is woven into ocean life, a thread reaching down to creatures with no eyes to see the sky, and yet somehow keeping time with it regardless. Long before any tide could be predicted by machine or measured by satellite, the people who lived along the world's coastlines learned to read the moon as a kind of quiet calendar for the sea. Fishing communities noticed, generation after generation, that the height and timing of the water followed the moon's phase in a dependable pattern, higher tides gathering around the new and full moon, gentler ones in between. Boats were launched and returned according to the tide, timed to cross shallow harbor bars or river mouths only when the water stood high enough to carry them safely. Nets and traps were set to catch fish moving with the incoming or outgoing water, since many species seem to feed and travel along with the tide. Along muddy or rocky shorelines, families gathered shellfish at low tide, walking out onto ground that would be underwater again within hours. This knowledge, refined over centuries and passed down long before it was written in any book, let coastal people work with the moon's rhythm rather than against it, trusting a light in the sky to signal when the sea was ready to be met. The moon does not glow with its own light. It simply reflects sunlight, and at every single moment, exactly half of its surface is bathed in that soft daylight, while the other half rests in darkness, the same way half of the earth is always lit while the other half sleeps beneath the stars. What changes night after night is not the moon itself, but our quiet vantage point. As the moon slowly circles the earth, the angle between the sun, the earth, and the moon shifts, degree by patient degree, and so we see a different slice of that sunlit half. Sometimes we catch only a slender curve of light along one edge, a thin crescent hanging low. Other times we see the whole glowing face turned fully toward us. This gentle, repeating dance is the entire secret behind the phases. No hidden mechanism, no changing light source, only simple geometry unfolding slowly across the sky. Astronomers sometimes say the moon is only half awake and half asleep at any given time, and that from Earth, we are simply watching that soft boundary drift, tracing the same unhurried path it has traced for billions of quiet years. There are two gentle ways to measure the moon's month, and the small difference between them tells a quiet story about how the Earth and moon move together through space. The first is called the sidereal month, the true orbital period, the time the moon takes to complete one full circle around the Earth relative to the distant, fixed stars, which comes to about 27 1/3 days. The second is the synodic month, the one tied to the phases we actually see, lasting closer to 29 1/2 days. The reason for this small gap is soft but simple. While the moon is circling the Earth itself is also gliding forward on its own long journey around the sun. So once the moon completes its true orbit, the sun has shifted position slightly, and the moon must travel a little further, about 2 extra quiet days, to line up with the sun again. This is why the calendar month and the moon's true orbit never quite match. Two slow cycles, nested one inside the other, drifting gently out of step and back into step, the way two unhurried walkers might slowly fall behind and catch up again. Of all the moon's phases, two feel like resting points, quiet endpoints in the slow monthly swing between darkness and light. The new moon comes when the moon sits almost between the Earth and the sun, its sunlit half turned fully away from us, so that from Earth the moon seems to vanish into the night, leaving the sky unusually dark and open for the stars. The full moon comes 2 weeks later, when the Earth stands roughly between the sun and the moon, and the entire sunlit face turns toward us at once, rising as the sun sets, a whole round light easing gently above the horizon. Between these two calm points, the moon quietly waxes and wanes, growing from a slim crescent into a full glowing circle, then slowly thinning again back toward darkness. Astronomers think of new moon and full moon less as opposites and more as two ends of the same soft breath, one drawing the sky's light inward until it disappears, the other releasing it fully back into the night. Every culture that ever watched the sky noticed these same two moments, the quiet dark and the full glow, marking the gentle turning points of the month. A lunar eclipse happens on a night when the Earth quietly slips directly between the sun and the full moon, casting its own broad shadow across the moon's sunlit face. Because the moon is so much smaller than the Earth, this shadow can cover it completely for a while, and during that time something soft and beautiful happens instead of simple darkness. Sunlight passing through the thin ring of Earth's atmosphere bends gently inward, the same way it bends at every sunrise and sunset, and the shorter blue light scatters away, while the longer red and orange light curves quietly onward, falling across the moon like the last light of evening. This is why a total lunar eclipse often turns the moon a soft, warm, coppery red rather than leaving it dark, an effect people have gently nicknamed a blood moon, though there is nothing alarming in it at all, only sunlight traveling the long way around, borrowed from every sunrise and sunset happening on Earth at that same quiet moment. It can only happen at full moon when the alignment is right, and it unfolds slowly over an hour or more, giving anyone watching plenty of unhurried time to notice the color change. A solar eclipse happens when the moon, at new moon, passes directly between the Earth and the Sun, casting its comparatively small shadow onto part of the Earth below. Where that narrow shadow falls, the moon appears to cover the Sun, and for a brief, hushed moment, day dims gently toward twilight. By a quiet coincidence of size and distance, the moon and the sun appear almost exactly the same size in our sky, close enough that the moon can, under the right conditions, cover the sun's bright face completely, revealing the soft pale glow of its outer atmosphere. Yet a total solar eclipse is rare for any single place on Earth, because the moon's darkest shadow, called the umbra, traces only a thin path across the planet's wide surface, often just 100 miles or so across, while the Earth keeps turning and the moon keeps moving along its tilted orbit. Any one town might wait centuries between total eclipses passing directly overhead, even though somewhere on Earth, a solar eclipse of some kind occurs a few times most years. It is less a rare event in the universe and more a rare gift to any particular quiet patch of ground. Long before anyone understood why eclipses happened, ancient skywatchers noticed something quietly remarkable, that eclipses seem to return in a slow, patient rhythm. This pattern is now called the Saros cycle, a span of about 18 years, 11 days, and a few hours, after which the sun, earth, and moon return to nearly the same alignment relative to one another. Astronomers believe the earliest careful observers of this rhythm may have lived among the Babylonian and Chaldean skywatchers, who kept quiet, patient records of the sky across many generations, long enough for such a slow pattern to reveal itself. Once one Saros cycle completes, a similar eclipse tends to occur again, shifted a little in geography but closely related in character, part of a longer family of eclipses stretching back and forward across centuries. Modern astronomers still use the Saros cycle today, alongside far more precise calculations, to trace the gentle, orderly clockwork behind when and where eclipses will fall. There is something soothing in knowing that these events, which once seemed so mysterious, follow a rhythm patient enough to be written down, studied, and quietly predicted, a reminder that the sky, however vast, keeps a kind of slow and dependable time. Although the moon is tidally locked, always turning the same face toward the Earth, careful skywatchers eventually notice something gentle and unexpected, that the moon seems to rock slightly from side to side and nod up and down over time. This soft rocking motion is called libration, and it happens for a few quiet reasons. The moon's orbit is not a perfect circle, so its speed changes slightly as it moves closer to and farther from the Earth, while its rotation stays steady, letting us peek a little around each edge in turn. Its axis is also tilted slightly compared to its orbit, adding a small nodding motion as well. Taken together, these gentle wobbles mean that over time, an unhurried observer on Earth can see about 59% of the moon's surface, not the 50% we might expect from a perfectly locked companion. The extra sliver revealed at the edges never appears all at once, only a thin strip at a time, trading places with a thin strip lost on the far side. It is a slow, quiet motion, far too small to notice on any single night, but one that reveals itself patiently across many nights of watching. Long before satellites and calendars, people who lived close to the land gave each full moon of the year its own gentle name, tied to the season it arrived in. In many Native American and early colonial traditions, the full moon of early autumn, the one falling nearest the equinox, became known as the harvest moon, prized because it rises around sunset for several evenings in a row, offering extra soft light for gathering the last crops of the season. Other months carried their own quiet names as well: a wolf moon in the depths of winter, a snow moon soon after, a worm moon as the ground began to soften, a strawberry moon in early summer, and a hunter's moon following the harvest moon into the cooling days of fall. These names varied gently from region to region and people to people, shaped by whatever the land was doing at that time of year: animals moving, plants ripening, snow falling. None of them changed anything about the moon itself, which shone exactly as it always does, but they gave communities a soft, shared language for marking time, a calendar written in light, season folding quietly into season, one full moon at a time. On certain evenings, especially a few days after new moon, a careful observer looking at a slim crescent moon low in the sky might notice something soft glowing faintly within the darkened part of its face, a pale, ghostly roundness completing the circle that the bright crescent alone does not show. This gentle glow is called earthshine, and it comes from sunlight that has already reached the earth, reflected off clouds, oceans, and pale deserts, then traveling back out across space to land softly on the moon's dark side, before a small fraction of it quietly returns to our eyes. Earthshine is, in effect, borrowed light reflected twice, arriving faint and silvery rather than bright. Old sky watchers, noticing this soft completion of the crescent, described it poetically as the old moon resting in the new moon's arms, a gentle image for a gentle glow. Earthshine is easiest to notice in the quiet hour just after sunset or just before sunrise, when the sky is dark enough to reveal it but the crescent itself is still comfortably visible. It is a small, easily missed detail, a reminder that Earth too glows softly out into the dark, just as the moon glows for us. Most months carry exactly one full moon, following the moon's steady rhythm of about 29.5 days. But because most calendar months run slightly longer than that, every 2 or 3 years a single month manages to fit 2 full moons within its borders, one near the very beginning and one near the very end. The second of these 2 full moons has picked up a quiet nickname over time, the blue moon, though the name has nothing to do with its actual color. On the night of a blue moon, the moon looks exactly as soft and pale and familiar as it always does, no tint of blue anywhere upon it. The phrase likely grew from an old, half-forgotten turn of language where blue once suggested something rare, and over time it settled onto this calendar quirk. This is where the gentle saying comes from, that something happening once in a blue moon happens only rarely. It is less an event in the sky and more a small trick of timing between the moon's ancient rhythm and the calendar's tidier count of days. Long before clocks or written history, people everywhere noticed that the moon changed shape in a steady, repeating rhythm, and they began to build their sense of time around it. A lunar month, the stretch from one new moon to the next, became one of the first units humans used to organize their lives, long before anyone understood why. Many early civilizations, including those in Mesopotamia, China, and among various indigenous peoples, kept calendars that followed the moon closely, counting days by its phases and marking festivals by its fullness. Because 12 lunar months fall short of a full solar year by about 11 days, some cultures developed what is now called a lunisolar calendar, gently adding an extra month every few years to keep their calendar in step with the seasons. This quiet correction allowed planting times and festivals to stay aligned with the seasons. Versions of this lunisolar approach still exist today, in calendars such as the Hebrew and Chinese calendars, carrying forward a rhythm first noticed by ancient eyes turned upward. In this way, the moon helped give early human life its first steady, shared sense of passing time. Scattered across the ancient world are quiet stone structures that seem to have been built, at least in part, with the moon in mind. Stonehenge, rising on a gentle English plain, is the most famous example, and researchers have long noticed that some of its alignments correspond not only to the sun's movements, but to the more complex, slowly shifting path of the moon along the horizon. This lunar path follows a longer pattern than the sun's yearly one, taking about 18.5 years to complete a full cycle, and evidence suggests some ancient builders were patient enough to notice and track it. Similar careful attention appears at other ancient sites, from earthen mounds to standing stones, where entrances seem to face points where the moon rises or sets at key moments in its long cycle. Archaeologists remain gently divided on how precisely these builders understood what they tracked, and it is wise to hold such ideas loosely. Still, the alignments themselves suggest something moving and simple. Communities, working across generations, choosing to orient their most lasting monuments toward the slow, dependable wandering of the moon, as if to hold its rhythm in stone. Across the world, in cultures separated by oceans and centuries, people looked up at the moon and wove it gently into their stories. In ancient Greece, the moon was often connected with the goddess Selene, imagined as quietly driving her pale chariot across the night sky. In Roman tradition, a similar figure, Luna, carried forward that same soft image of a heavenly light in motion. Chinese folklore offers the peaceful tale of Chang, who is said to live on the moon, sometimes accompanied by a gentle rabbit pounding herbs, an image still recalled during the Mid-Autumn Festival. In parts of indigenous American tradition, the moon has been honored as a grandmother figure, a quiet keeper of time and cycles. Norse stories spoke of Mani, who guided the moon through the sky in its own slow, steady course. What is gentle to notice is not any single shared story but a shared instinct. Nearly every culture, watching the same silver light, felt moved to imagine it as alive with meaning. These old stories were never meant as explanations in the scientific sense. Historians view them instead as reflections of how deeply the moon settled into human imagination. Among the most patient watchers of the night sky were the astronomers of ancient Babylon, who lived in the region we now call Iraq, and left behind some of the oldest detailed records of the moon's behavior. Using clay tablets and a wedge-shaped script called cuneiform, these skywatchers noted the moon's position night after night, year after year, slowly building an archive of observation that stretched across generations. They worked with no telescope, only careful eyesight and a willingness to keep quiet, consistent notes long after the novelty of watching had worn off. Over time, this record allowed them to notice subtle patterns in the moon's motion, including the timing of eclipses, which they learned to anticipate with real skill. Historians believe this careful record-keeping laid some of the earliest groundwork for later mathematical astronomy, influencing sky watchers in Greece and beyond. There is something quietly moving about imagining these ancient observers, generation after generation, returning to the same rooftops, eyes lifted to the moon we still see tonight, each adding one small mark to a record none would live to see completed. Their patience, more than any single discovery, is what still speaks softly across the years between their time and ours. In the early 17th century, a new kind of quiet arrived for anyone willing to point a simple telescope toward the night sky. The Italian astronomer Galileo Galilei was among the first to turn this new instrument toward the moon, and what he saw gently overturned centuries of assumption. Rather than a smooth, perfect sphere, as many had long imagined, Galileo observed a surface marked by mountains, valleys, and countless craters, catching sunlight and shadow much as rugged ground might. He noticed how the boundary between light and dark on the moon's surface, called the terminator, was not a clean, even line but a rough and irregular one, and he reasoned that this roughness came from real highlands and hollows. He even made careful attempts to estimate the height of lunar mountains by studying the small shadows they cast. Galileo recorded his observations in sketches and in a short, quietly influential book, sharing what his eyes had found with anyone curious enough to read it. His work marked one of the first times human eyes, aided by glass and patience, saw the moon not as a flawless heavenly light, but as an actual place, floating quietly in the dark just as it does tonight. Once early telescopes revealed that the moon had real texture, a natural next step followed quietly. Someone needed to draw what was actually there. In the years following the first telescopic observations, several careful observers across Europe began producing the earliest maps of the moon's visible surface, working slowly by candlelight and careful eye. Thomas Harriot in England is now credited with sketching some of the very first telescopic drawings of the moon, slightly before Galileo's more famous work. Later in the 1600s, astronomers such as Johannes Hevelius, working from his own rooftop observatory, produced detailed and remarkably careful lunar maps and atlases, patiently naming mountains and other features after earthly landmarks he knew well. Around the same period, the astronomers Giovanni Battista Riccioli and Francesco Grimaldi created a naming system for lunar features that endures in modified form even now, gently assigning the dark plains their poetic names. These early cartographers worked without photography, relying instead on long nights, steady hands, and repeated observation to confirm what they had seen. Their quiet, careful maps turned a distant light into a place with geography, a companion whose surface could finally be studied, named, and slowly, patiently understood. For as long as people have written and painted, the moon has drifted softly through their pages and canvases. Ancient poets wove it into verses about longing and distance, and centuries later, Romantic era poets returned to it again and again as a symbol of quiet reflection, memory, and the passage of time. In classical Chinese poetry, the moon appears with particular tenderness, often linked with thoughts of faraway family and gentle homesickness, a single shared light connecting people who could not otherwise be together. Painters, too, found themselves drawn to it, using moonlight to soften a landscape or cast a scene in silver stillness, suggesting calm, mystery, or wistful melancholy. Composers reached for it as well, shaping slow, gentle passages meant to evoke its soft glow, some still played today at day's end. What ties these countless works together across languages and centuries is how rarely the moon is treated as ordinary. Again and again, it becomes a mirror for whatever feeling an artist already carried: distance, longing, peace, or wonder. Long before science explained what the moon truly was, human imagination had already made it into a quiet, faithful companion, ready to receive whatever we chose to see in it. The very word we use for month traces its roots back to the moon itself, a small linguistic clue pointing to how deeply lunar rhythms shaped early human timekeeping. In English and in many other languages, the words for moon and month share the same ancient root, a quiet reminder that before clocks or written calendars, the clearest way to mark a span longer than a day was simply to watch the moon complete one full cycle of its changing shape. From new moon to new moon takes a little more than 29.5 days, a span easy enough for anyone to observe by eye, night after night. Early people needed no explanation of orbits or gravity to notice this steady rhythm. They only needed patience and a clear sky. Over time, this observed cycle became a practical, shared unit, useful for planning journeys, gatherings, and the passing of seasons. Even today, long after calendars became mathematically exact, we still speak in months, unknowingly echoing that ancient habit of watching the sky. In this quiet way, the moon did not just inspire early timekeeping. It left its own name gently folded into the language we still use to describe time. In farming communities across many parts of the world, old traditions grew up around the idea that the moon's phases might gently influence the land. Some traditions held that crops growing below the soil were best planted as the moon waned, while crops that grow upward and outward were better started as the moon waxed toward fullness. Others linked the full moon with easier nighttime harvesting, since its brighter light allowed work to continue safely after sunset. These beliefs passed quietly from one generation of farmers to the next, often through almanacs that listed planting dates alongside the moon's expected phases. Modern science has not found strong evidence that the moon's light or gravity meaningfully affects seed germination or crop growth, and it is worth holding these old customs gently, as cultural tradition rather than settled fact. Even so, the underlying instinct feels understandable. For farmers whose lives depended on careful timing, the moon was the most visible, most reliable clock available, faithfully repeating its cycle above every field. Whether or not it truly shaped the harvest, it certainly shaped how people thought about their work, offering a steady, comforting rhythm to follow through the long agricultural year. Before compasses were common and long before satellites could fix a traveler's position instantly, the moon quietly offered its light and its position as a kind of gentle guide. Sailors moving across open water at night relied on moonlight simply to see their surroundings, to make out the shape of waves, coastlines, or the edges of their own ship in the dark. More than that, careful observers learned to use the moon's position relative to the stars as a rough method of tracking direction and even estimating time during the night. Desert travelers and caravan guides likewise moved by moonlight when the sun's heat made daytime travel difficult, letting the moon's glow light a safer path across open, featureless ground. Later, more formal navigational methods, such as measuring the moon's angle against the horizon or nearby stars, allowed sailors to estimate their location on the open ocean with growing precision. In all these quiet ways, the moon served less like a scientific tool and more like a steady companion, always present, always predictable in its slow movement, offering the kind of dependable light a traveler far from home could still trust night after night to find the way forward. Long before any human eye looked back at Earth from lunar distance, small unmanned spacecraft made the first quiet attempts to reach the moon. In the late 1950s, engineers on both sides of the Atlantic began sending simple probes outward, hoping merely to prove that a machine built on Earth could cross that dark, silent gap of space. Many of these early attempts, part of programs remembered today under names like Pioneer and Luna, ended without success, lost to launch troubles or missed trajectories, and only a few even left Earth's immediate neighborhood. Luna 1, launched in January of 1959, became the first human-made object to pass near the moon and drift onward into orbit around the sun. A small traveler guided by careful calculation rather than by any living hand. Soon after, Luna 2 became the first spacecraft to reach the moon's surface directly. These missions carried no drama in the retelling, only steady progress, each flight slowly teaching something the next one would use. They were humanity's first small footsteps, taken not by feet but by metal and radio signals, reaching toward a companion that had hung in the sky, untouched for the entire span of memory. In October of 1959, a small Soviet spacecraft named Luna 3 accomplished something no living being had ever managed before. It looked upon the far side of the moon, the hidden hemisphere that never turns to face the Earth. Because the moon keeps the same face toward us at all times, generations of skywatchers, poets, and astronomers had gazed upward for thousands of years, without ever glimpsing what lay on the other side. Luna 3 changed that gently, circling behind the moon, and using an onboard camera to capture a series of grainy photographs, developed automatically within the spacecraft itself before being scanned and radioed back to listening stations on Earth. The images that arrived were faint and soft-edged, more shadow than detail, yet they revealed something remarkable. A landscape rougher and more mountainous than the familiar near side, with far fewer of the smooth, dark plains known as Maria. Scientists studying those first far-away pictures found a hemisphere quieter in appearance yet busier in texture, pale highlands stretching in every direction. It was a gentle unveiling, achieved not through eyes but through patient machinery, letting humanity complete, at last, its first calm look at the whole small world turning silently beside our own. By the early 1960s, a new goal had steadily taken shape within the American space program: to send human beings safely to the surface of the moon and bring them home again. This effort became known as the Apollo program, and it unfolded slowly and carefully across the decade, built upon years of earlier flights that tested how people might live, work, and maneuver in the emptiness beyond Earth. Engineers designed a towering rocket called the Saturn V, tall enough to lift a small crew and their spacecraft far beyond Earth's gentle pull, while a separate lunar module was built to carry astronauts down to the surface and lift them safely back to lunar orbit. Each mission added a new piece of confidence, testing navigation, docking, and how the module would behave in the thin, silent vacuum near the moon. Nothing about the plan was rushed. Every rehearsal in orbit was treated as essential practice for the quiet, careful descent that would eventually follow. By the time the program was ready for its historic attempt, thousands of engineers, scientists, and flight controllers had spent years preparing calmly for a journey meant to be measured not in glory, but in safe and steady returns. On a quiet July night in 1969, two astronauts named Neil Armstrong and Buzz Aldrin guided a small lunar module down onto a wide, dusty plain known as the Sea of Tranquility, while their crewmate Michael Collins continued orbiting gently overhead in the command module. Hours later, Armstrong climbed down a short ladder and placed his boot upon the fine gray soil, becoming the first human being to stand on ground beyond the Earth. He described the moment simply, calling it one small step for a man and a giant leap for mankind, words that generations have since remembered as softly as the moment itself. Aldrin followed soon after, and together the two men spent a little over 2 unhurried hours walking across the still, airless surface, collecting samples, setting up simple instruments, and pausing now and then to take in a view no one before them had ever seen firsthand. Above them stretched a black sky filled with steady, unblinking stars, and beneath their boots lay dust that had waited undisturbed for countless ages. It remains remembered not as a moment of danger, but as a peaceful arrival, humanity's gentle first contact with a world it had only ever watched from far away. Across 6 separate landings, Apollo astronauts carefully gathered pieces of the moon itself, filling padded containers with rock and soil to carry home to Earth. In total, they returned with several hundred pounds of lunar material, ranging from fine gray dust to solid fragments of ancient volcanic rock, each piece chosen from the ground around their landing sites. Back on Earth, these samples were sealed away in special facilities designed to protect them from moisture, air, and contamination, and only small portions have ever been opened for study. Scientists have spent decades since carefully examining this material, and research on these same handful of samples continues even today, often using instruments far more sensitive than anything available when the rocks first arrived. From this patient study came some of the clearest evidence for how the moon likely formed, how old its surface is, and how little it has changed over immense stretches of time. A small number of samples remain deliberately untouched, set aside for future scientists working with tools not yet invented. In this way, a handful of quiet gray stone continues to speak softly across the decades, offering a little more of its story each time someone troubles to listen. Exploring the moon did not always require a human passenger. In November of 1970, the Soviet Union landed a small 8-wheeled robot named Lunokhod 1 onto the lunar surface, where operators back on Earth guided it gently across the dust for many months, using slow radio commands sent across the great hushed distance between the two worlds. It became the first wheeled vehicle to roam another world, moving in careful, unhurried stretches while cameras relayed images of the ground ahead. A few years later, human explorers gained their own set of wheels. Beginning with the Apollo 15 mission, astronauts brought along a small battery-powered vehicle known as the Lunar Roving Vehicle, foldable and light enough to fit aboard the lunar module, yet sturdy enough to carry 2 astronauts and their equipment across several miles of open ground. With it, later Apollo crews could travel much farther from their landing site than earlier astronauts on foot, reaching craters, hills, and boulders that would otherwise have stayed out of reach. Together, the robotic Lunokhod and the crewed rover offered 2 gentle answers to the same quiet question of how best to stretch a short visit into a longer, wider journey across unfamiliar ground. In December of 1972, the astronauts of Apollo 17 lifted off from the lunar surface and returned home. And though no one announced it at the time as any kind of ending, those quiet moments marked the last occasion human footprints would be freshly pressed into lunar soil for many, many years to come. The Apollo program concluded soon after, its goals largely met, and attention on Earth slowly turned toward other pursuits, including the building of space stations closer to home and the careful, steady work of robotic exploration further out into the solar system. The moon itself did not go entirely unvisited during this long stretch, as occasional robotic spacecraft continued to orbit or study it faithfully from a distance. But for decades, no human eye looked upon its gray hills from just a few feet away. Entire generations grew up watching the moon rise each night, without any living memory of footsteps having once been left upon it. This long pause was never a forgetting, only a patient interval, filled instead with new priorities and new technology, before attention would eventually, gently, begin turning back toward that same still, familiar companion in the sky. In more recent decades, interest in the moon has steadily returned, carried forward by new missions from around the world. China's Chang program, named gently after a moon goddess from ancient folklore, has sent a steady series of orbiters, landers, and small rovers to the lunar surface, including a mission that achieved the first soft landing on the moon's far side and another that gathered fresh samples and carried them back to Earth. Other nations, too, have sent their own quiet visitors, expanding a shared understanding of this familiar neighbor one careful mission at a time. Meanwhile, NASA has been developing its Artemis program, named fittingly after the twin sister of Apollo in ancient myth, with the long-term goal of returning astronauts to the lunar surface and eventually supporting a longer, steadier human presence there. Early Artemis missions have focused on testing new rockets and spacecraft, first without crew and later carrying astronauts back into lunar orbit, each step taken as carefully and deliberately as those of the earlier era. Taken together, these newer efforts feel less like a race and more like a slow, patient continuation, humanity softly picking up a long conversation with the moon that had merely paused for a while. Near the moon's poles lie craters so deep that sunlight never quite reaches their floors, leaving certain hollows in permanent, unbroken shadow across the entire span of the lunar day. Within these dark, extremely cold pockets, temperatures stay low enough to preserve ice for immense stretches of time, and scientists have long wondered whether water might be resting there, undisturbed for billions of years. Orbiting spacecraft carrying sensitive instruments detected signs consistent with hydrogen in these regions, and in 2009, one mission deliberately sent a spent rocket stage into one such shadowed crater, watching the resulting plume for signs of water, which it found. Since then, further missions have continued studying these silent, sunless craters from orbit, mapping where ice might be thickest and easiest to reach. The interest is not only scientific, since water hidden in these cold shadows could one day support future visitors, offering drinking water, breathable oxygen, or even fuel, without needing to carry every drop from Earth. For now, this ice waits quietly where it has waited all along, tucked into darkness at the edges of a world otherwise washed in open sunlight, patient and unseen, in craters that time itself seems to have gently overlooked. Looking ahead, space agencies and engineers have begun sketching gentle, early plans for what a longer human stay on the moon might someday look like. Rather than brief visits, these ideas imagine a steadier presence, perhaps a small collection of shelters near the lunar South Pole, close to those shadowed craters where ice may lie waiting, and within reach of nearby slopes that catch nearly constant sunlight for power. Designers speak softly of habitats built partly underground or covered in lunar soil for protection, and of equipment that might one day turn local dust and ice into water, air, or fuel, reducing what must be carried from Earth. None of this is expected quickly. Most who study it describe a slow accumulation of small steps, robotic missions first, then short crewed visits, and only gradually anything permanent. It remains, for now, a hopeful sketch more than a finished plan, drawn patiently by people who see the moon not as a destination to conquer, but as a quiet neighbor worth understanding more deeply. And so the story of these lunar journeys continues, unhurried, the way most lasting things tend to begin. Beneath the moon's pale surface lies a crust made largely of silicate rock, the same broad family of minerals that forms much of the ground beneath our feet on Earth. In the bright highlands, this crust runs rich in a mineral called feldspar, specifically a calcium and aluminum type that cooled into a light, almost frosted rock known as anorthosite. Scientists believe this rock slowly rose to the surface long ago, floating upward through a churning sea of molten material, the way a thin layer of cream gathers quietly atop a pail of warm milk. Because this feldspar-rich rock is comparatively light in both color and weight, it forms the brighter regions we still see from Earth on a clear night. Chemically, lunar crust shares a real kinship with Earth's own rocky materials, a soft echo of the two worlds' shared beginnings. And yet, unlike Earth's restless crust, folded and renewed by moving plates, the moon's crust has simply rested, largely undisturbed for eons, its ancient minerals preserved like a letter left unopened in a quiet drawer. So the next time moonlight settles across a windowsill, it is worth remembering that light has traveled from rock far older than nearly anything on our own changing Earth. Across the dark, smooth plains that early astronomers once mistook for seas, lies a very different kind of rock from the pale highlands above them. This darker material is basalt, a heavy, fine-grained volcanic rock rich in iron and magnesium, and in some regions in titanium as well. It formed when vast floods of lava, released by ancient impacts that cracked deep into the moon's interior, welled up and spread slowly across low basins before cooling into solid stone. On Earth, rock of a very similar family can be found in quiet volcanic landscapes, such as the dark shorelines of Hawaii or the broad basalt fields of Iceland, a gentle reminder that the same simple processes of melting and cooling shape more than one world. Because basalt holds more iron than the lighter highland rock, it absorbs more light rather than reflecting it, part of why these plains appear so much darker under a quiet study of moonlight. These flows did not happen quickly by our reckoning. They unfolded across long ages, layer resting upon layer, each one cooling in near silence long before there were eyes anywhere nearby to watch it happen or wonder at the slow, patient shaping of a world. Deep beneath all that rock, at the very center of the moon, rests a core far smaller than one might expect for a body its size. Scientists did not have to guess at this from a distance alone. During the Apollo missions, astronauts placed sensitive seismometers on the lunar surface, quiet instruments left behind to listen long after the astronauts themselves returned home. By studying how faint vibrations traveled through the moon over the years that followed, researchers were able to gently trace the outline of what lies beneath, layer by layer. What they found was a small core, likely rich in iron, with an outer portion that seems to remain at least partly molten even now, wrapped perhaps around a solid inner heart. Compared with Earth's own core, which makes up a large share of our planet's mass, the moon's core is modest, a small ember resting at the center of a mostly rocky, solid body. This gentle warmth at the moon's center is one of the last quiet traces of the heat left over from its fiery birth, a slow-fading glow that has been cooling, largely unnoticed, for billions of patient years beneath an unmoving surface. Unlike Earth, wrapped in its thick, moving blanket of air, the moon holds almost nothing above its surface that could be called a true atmosphere. What little exists is so thin and so sparse that scientists give it a gentler name, an exosphere, where the few scattered atoms drifting above the ground are so far apart that they rarely even collide with one another. Because there is no real air, there is no wind to stir the dust, no clouds to drift past, and no weather of any kind to speak of, not one gentle breeze in billions of years. There is also no erosion as we know it on Earth, no rain to wear down stone, no rivers to carve valleys, so footprints and rover tracks can remain sharp and undisturbed for an immense stretch of time. Without air to scatter sunlight, the lunar sky stays black even under the full brightness of day, with stars quietly visible whenever the sun's glare is blocked. And without air to carry vibration, sound itself has nowhere to travel, leaving the moon in a profound, unbroken silence that has rested over its surface since long before the first quiet footstep ever touched it. One of the gentler differences between Earth and the moon is simply a matter of pull. Gravity at the lunar surface is only about 1/6 as strong as the gravity felt here at home, a soft, easy tug rather than the firmer hold we are used to. Anyone standing on the moon would weigh far less than on Earth, and objects released from the hand would drift downward more slowly, settling with an almost unhurried grace. This is part of why the Apollo astronauts moved in long, bounding steps rather than an ordinary walk, each stride carrying them further and holding them aloft just a little longer than instinct expected. This same gentle gravity also played a quiet role in the moon's long history, since it was too weak to hold on to much of an atmosphere, letting whatever light gases once surrounded the young moon slowly drift away into space over time. Even lunar dust behaves differently under this softer pull, settling and clinging in its own unhurried way. It is a small, quiet detail, easy to overlook, yet it shapes nearly everything about how the moon behaves, how it rests, and how anything moves calmly across its ancient, silent ground. Long after the last footprints were pressed into lunar soil, a set of quiet instruments kept listening. The seismometers left behind by Apollo astronauts recorded something unexpected. The moon trembles, ever so gently, in what scientists came to call moonquakes. There is nothing alarming about them. They are subtle shifts, small and slow, more a soft settling than anything resembling the shaking familiar to us on Earth. Some, known as deep moonquakes, seem to occur when Earth's gravity gently tugs and flexes the moon's interior as the two bodies move together through their unhurried orbit. Others are shallow, their cause still less certain, while some tremors appear simply to follow the temperature swinging between lunar day and lunar night, as rock quietly expands and contracts. A few, fainter still, come from small meteoroids tapping the surface far above. Instruments recorded these tremors continuing for long minutes at a time, the moon's dry, unbroken rock apparently allowing vibrations to linger and ring gently rather than fade at once, the way a soft sound might last inside a calm, hollow bell. Scientists still study this quiet trembling today, less a mystery to fear than a soft, curious rhythm running deep beneath an otherwise still and silent world. Hold a compass on the moon today, and it would find almost nothing to guide it. Unlike Earth, which is wrapped in a steady, invisible magnetic field strong enough to turn a needle and shield the surface far below, the Moon today carries only a weak, uneven trace of magnetism, scattered here and there across the ground rather than wrapped evenly around the whole world. Yet certain rocks collected and brought home by Apollo astronauts tell a quieter, older story. When scientists examined them closely, they found signs that these rocks had been gently magnetized long ago, evidence that the young Moon likely once possessed a real global magnetic field, generated deep inside by a molten, churning core, not unlike the process that powers Earth's own field even now. Scientists believe that as the Moon's small core gradually cooled and its churning slowed, this ancient field softly faded, leaving behind only faint magnetic whispers preserved in old stone. Today those patches sit quietly scattered across the surface, small fossils of a more active past, a gentle reminder that the Moon, too, once held an inner restlessness that has long since settled into the calm stillness we see there today. Scattered invisibly through the fine gray soil covering the Moon's surface are small traces of a light gas called helium-3, along with a handful of other elements gathered there slowly over an immense stretch of time. None of it arrived through any activity of the Moon itself. Instead, it drifted in gently on the solar wind, a faint stream of particles constantly flowing outward from the Sun, settling into the lunar soil grain by grain across billions of quiet years. Because the Moon has no real atmosphere to turn such particles aside, its surface has simply gathered and kept them, patiently, the way a windowsill collects dust undisturbed for years on end. Researchers have long found this gentle accumulation interesting, and some have wondered, in a still largely theoretical way, whether helium-3 might someday serve as a resource for energy on Earth, though no such use exists yet outside of early study. Traces of other useful elements rest quietly in that same soil as well. For now, these remain small, patient details, resources simply waiting in stillness, undisturbed in the fine dust of a world that has kept careful, unintentional record of the Sun's steady breath for longer than human history has existed. Near the Moon's poles, tucked inside certain deep craters, are places sunlight never seems to reach. Because the Moon's axis tilts only slightly, sunlight there skims low across the ground rather than rising overhead, leaving the floors of some polar craters in permanent, unbroken shadow, hidden from daylight for what scientists believe may be billions of years without a single ray reaching down to touch them. Without any sunlight to offer even the smallest warmth, these hidden hollows have grown extraordinarily cold, among the coldest places ever measured anywhere in the solar system, colder even than the frozen, distant surface of Pluto. In this deep, undisturbed chill, scientists have found evidence of water ice, quietly held within the shadowed soil, likely delivered long ago by comets or icy asteroids, and preserved since by the sheer permanence of the cold and dark. With no air, no light, and no warmth ever reaching these crater floors, whatever ice rests there has had little reason to change, sitting in patient stillness while the rest of the Moon has passed through countless cycles of day and night above. It is one of the quietest, coldest corners known to science, a pocket of stillness tucked inside an already silent world. Step back from all these small details for a moment, and the Moon's overall makeup tells a quiet story of its own through two simple measurements: density and mass. The Moon's density, meaning how tightly its material is packed together, works out to a little over 3 grams for every cubic centimeter, notably lower than Earth's own density of about 5.5. This gentle difference matters, because it suggests the moon holds proportionally far less iron and other heavy metal than Earth does at its center, and proportionally more of the lighter rocky material found in a crust and mantle. In terms of mass, the moon is comparatively light as well, holding roughly 1/80th of Earth's, a modest companion drifting alongside a far heavier world. Taken together, these gentle numbers support the broader, softer picture scientists have pieced together of the moon's origin, a body built largely from rocky material rather than dense metal. It is quiet evidence, numbers rather than images, yet it tells us something real. The pale, silent companion overhead is, at its heart, a lighter world simply made, resting in the dark beside its heavier, busier neighbor. Earth spins on a tilted axis, leaning about 23.5 degrees, and this gentle line is the quiet reason the seasons arrive the way they do, one flowing softly into the next. Over vast stretches of geological time, the moon's steady gravitational pull has acted like a patient hand resting on a spinning top, keeping that tilt from wandering too far in either direction. Scientists who model these things believe that without a large moon, a planet's tilt can drift and wobble much more freely across millions of years, scrambling the rhythm of the seasons. Mars, whose 2 small moons are too light to offer that steadying pull, is thought to have swung through a much wider range of tilts over its history. Earth, held gently in place, has instead enjoyed a long, calm stability, letting summer and winter, planting time and harvest, return in the same soft pattern again and again. Countless plants, animals, and human cultures have built their lives around this dependable rhythm. In this quiet way, the moon works less like a distant light in the sky and more like an unseen keeper of balance, holding Earth steady so life below could settle into its own graceful rhythm. Long before anyone kept written calendars, many creatures of the sea seemed to already know the date, guided by the changing light of the moon overhead. Certain marine worms, corals, and fish time their reproduction to particular phases of the lunar cycle, often gathering to release eggs and sperm into the water within the same narrow window of just a few nights. The grunion, a small silvery fish found along the Pacific coast of North America, rides the highest tides that follow a full or new moon to lay its eggs in the wet sand, timing its arrival so precisely that observers can predict the very nights it will appear. Researchers believe these creatures likely sense a combination of moonlight and the shifting tides the moon creates, both working together as a kind of shared clock. This lunar timing helps scatter offspring across many nights rather than just one, and lets whole populations act together, which can improve the odds that enough young will survive. It is a gentle reminder that the moon's influence reaches quietly into the sea, shaping small lives that follow a rhythm written in light and tide, long before there were clocks or calendars to write it down for them. When darkness settles over land and sea, many nocturnal animals turn to the moon as a soft compass in the sky. Some night-flying insects appear to use the moon's steady position to help hold a straight line as they travel, keeping the distant light at a constant angle the way an old sailor might steer by a star. Certain migratory birds that travel by night are thought to draw on moonlight, along with the stars and Earth's magnetic field, as one of several gentle cues that help them find their way. Sea turtle hatchlings offer one of the most touching examples of all. After breaking free of their sandy nests, tiny turtles instinctively crawl toward the brighter, more open horizon, which over the ocean is usually lit by the reflected glow of the moon and sky, rather than the darker silhouette of dunes behind them. This simple instinct has guided countless generations of hatchlings safely to the water's edge. In modern times, artificial lights along coastlines can sometimes confuse this ancient guidance system, drawing hatchlings the wrong way. But under a natural, star-filled sky, the old partnership still holds, with moonlight quietly lending its glow to guide small travelers through the night. For centuries, people in many cultures have held a gentle belief that a full moon disturbs sleep or stirs restlessness, and this idea still lingers comfortably in conversation today. It is easy to understand why the thought took hold, since a bright full moon does wash the night in soft light, unlike any other night of the month. When careful researchers have actually gone looking for this effect, gathering sleep data across many nights, the evidence has turned out to be mixed at best. A few studies have reported people falling asleep a little later or sleeping a few minutes less around the full moon, while many other, larger studies have found no meaningful difference at all. Taken together, scientists generally agree that if there is any real effect of moon phase on sleep, it is small and easily lost among the ordinary things that shape a night's rest, such as light, noise, or worry. So the old belief may say more about the moon's beauty and its hold on human imagination than about anything measurable in the body. Either way, there is no need to worry over it tonight, only to notice the moonlight if there is any, and let the rest come naturally. Twice a day, in a rhythm set by the moon's gentle pull, a strip of shoreline known as the intertidal zone is slowly uncovered by the retreating sea, then just as slowly wrapped back beneath the waves. This narrow band, sometimes no wider than a quiet country road, is home to an entire world of small, resilient creatures that have learned to live with constant change. Barnacles seal themselves shut and wait out the dry hours. Mussels cling tightly to rocks in dense, patient colonies. Crabs tuck into damp crevices, and sea anemones fold their soft arms inward until the returning water lets them open again. Tide pools left behind by the falling sea become small, self-contained worlds for a few hours, warmed by the sun and filled with tiny fish, snails, and drifting life. Very few places on Earth demand so much adaptability, since the same patch of shoreline can be fully underwater and then completely exposed within hours. And yet this rhythm, repeated without fail across the ages, has produced one of the richest, most crowded neighborhoods in all of nature, shaped entirely by the patient, twice-daily breathing of the tides that the moon quietly conducts from above. Long before modern agriculture, farmers in many parts of the world followed the changing phases of the moon as a gentle guide for when to plant and when to gather their crops. Old traditions often suggested sowing leafy crops that grow above ground during the waxing moon, as the light grew fuller each night, and saving root vegetables like carrots and potatoes for the waning moon, as the light softened toward darkness. Some almanacs still printed today carry planting calendars built around this old wisdom, passed down grower to grower across generations. It is worth saying honestly that modern agricultural science has not found reliable evidence that moon phase changes how well seeds sprout or crops grow, and most researchers point instead to soil, weather, and season as the true drivers of a good harvest. Still, this lunar planting calendar deserves to be remembered fondly, not as a proven method, but as a beautiful piece of cultural heritage, shaped by patient observation of the sky by people who depended on the land for survival. In its own quiet way, it reflects a deep human instinct to look upward for order and a sense of rhythm even in the humblest rows of a garden. A healthy night for the countless creatures that live by darkness is not simply the absence of the sun, but a delicate balance between two kinds of night, the bright, moonlit kind and the deep, truly dark kind. Some animals depend on true darkness to feel safe, since many small mammals and insects are more vulnerable to predators under a bright moon, when their movements and shadows become easier to see. Owls and other night hunters, in turn, often find it easier to spot prey during these brighter nights, giving moonlight a very different meaning depending on which side of the hunt an animal happens to be on. Other creatures instead lean on moonlight itself as a needed guide for navigation or timing, and would struggle without it. Because of this, healthy nocturnal ecosystems seem to need both kinds of nights across a month, the softly lit and the completely dark, each supporting a different set of lives and behaviors. This is one reason many scientists have grown quietly concerned about the spread of artificial outdoor lighting, which can erase true darkness from the night sky, leaving little room for the ancient balance that moonlight and darkness once held in patient turn. On certain reefs around the world, once a year, something remarkably quiet and coordinated takes place beneath the waves under the light of a particular full moon. Many coral colonies across a wide stretch of reef release their eggs and sperm into the water within the same hour, on the same night, in an event sometimes described as an underwater snowfall, as pale, tiny bundles drift upward together through the dark water. This mass spawning has been especially well studied on Australia's Great Barrier Reef, where it typically follows the full moon in the warmer months, once water temperature and daylight length are also right. Scientists believe corals sense moonlight through light-sensitive proteins in their tissue, using it as a shared timing signal that lets colonies of the same species, spread across many miles of reef, release their offspring within the same narrow window. Spawning together like this, rather than in scattered efforts, is thought to improve the chances that eggs and sperm actually meet in the open water. It is a hushed, largely invisible event, unfolding far from human eyes, yet it stands as one of the more striking examples of how closely woven the moon remains into the quiet timing of ocean life. Across countless generations and cultures, the rising of the moon has carried a gentle, unspoken invitation to slow down, close the day, and rest. Long before electric light stretched the evening hours later and later, the appearance of the moon in the sky was one of the clearest signals that the working day was over, and that a quieter time had begun. Lullabies in many languages have called on the moon as a soft companion for sleepy children, asking it to watch gently over them through the night or help carry them off to dreams. Poets and songwriters have returned to it again and again as a symbol of calm and the peaceful stillness that settles over a house once the lamps are dimmed. Even simple evening walks taken to unwind after a long day often become small rituals of noticing the moon overhead, whatever shape it wears that night. This quiet thread runs through bedtime stories, old hymns, and porch conversations alike, treating the moon less as a distant rock in space and more as a familiar, comforting presence, one that has kept gentle watch over the closing hours of the day for as long as people have paused to look up and rest. It is a calm thought experiment for scientists to imagine Earth without its moon, not as a warning, but as a way of appreciating what the moon quietly provides. Without a large moon steadying its spin, Earth's axial tilt might wander more freely over time, the way researchers believe Mars's tilt has done, potentially producing seasons that swing more wildly than the gentle pattern life has grown used to. The tides would still exist, since the sun alone pulls at Earth's oceans too, but they would likely be smaller and gentler, lacking the fuller rhythm the moon adds to coastal waters. Nights would also grow darker on average, since even a slim crescent lends more light than most people notice until it disappears. Some researchers have gently wondered whether life's early development along tide-washed shores might have unfolded differently under stiller waters. None of this is meant to unsettle, only to invite quiet appreciation, since Earth did not turn out this way. The moon has been overhead through nearly all of our planet's story, a steady companion whose gentle influence reaches into seasons, tides, and the soft dark of every night. Of all the worlds humanity has ever reached, only one has felt the weight of a human footstep. Robotic explorers have landed on Mars, drifted through the clouds of Venus, and sent back images from moons and asteroids across the solar system. But the moon remains the sole place beyond Earth where human beings have actually stood, walked, and left the mark of their own feet in the ground. Between 1969 and 1972, 12 astronauts descended onto its surface, and for a handful of quiet days, the gray dust of another world held an ordinary human footprint, the kind that might be left on a beach or a garden path back home. It is a strange, gentle thought that for over half a century since, no other soil beyond our home planet has known that kind of visit. Every other body in the sky remains, for now, a place seen only through the eyes of machines and telescopes. The moon alone has been walked upon, touched by gloved hands, and gazed back at Earth from its silent ground. In the story of humanity's reach into the dark, it stands apart as the one small, silver exception, close enough to visit, quiet enough to remember. Because the moon has no wind and no rain or rivers to wash anything away, the marks left by the Apollo astronauts have hardly changed since the day they were made. The footprints pressed into the lunar dust, the tracks left by small rovers, the base stages of landers, and a few tools left behind all still rest exactly where they were set down, decades ago, untouched because the moon simply has no weather at all. On Earth, a single season of rain and wind can erase a footprint on a beach within hours. But on the moon, with no air to carry moisture or wear down the ground, there is nothing to smooth those edges away. Scientists believe these traces could remain recognizable for millions of years, worn down only by the occasional impact of tiny meteorites drifting in from space, a process so gradual it is almost impossible to notice on any human timescale. It is a quiet kind of permanence, footprints from a handful of days in the late 1960s and early 1970s, still sitting undisturbed in the dust, patient and unbothered, while generations on Earth are born, grow old, and are followed by generations after them. Very little in this world is shared by literally everyone, but the moon comes close. A person watching it rise over a quiet coastline is looking at the very same object as someone glancing up through city towers on the far side of the planet, or a traveler resting beside a fire in open desert, or a child at a window in winter. No passport, language, or border changes what is overhead. At any given moment, the moon sits above the horizon for roughly half of the entire Earth, meaning that at this very hour, a vast number of people scattered across dozens of countries and cultures may be looking toward the same pale shape in the sky without ever knowing about one another. Long before satellites or shared screens connected the world, the moon was already doing something like that quietly, offering the same view to farmers and city dwellers who had never heard of each other's countries. It asks nothing, belongs to no single nation, and appears the same to every observer regardless of what language they speak or what they believe. In that sense, it may be one of the oldest, gentlest shared experiences human beings have ever had in common. Every event in the recorded history of human beings has happened underneath the same moon. It hung in the sky over ancient cities built stone by stone, over quiet villages going about ordinary days, over long journeys made on foot or by ship, and over countless nights of rest in homes that no longer exist. It was there before written language, before agriculture, before the first fires were carefully tended through the dark. It watched in its silent and uninvolved way the rise and fall of empires, the slow spread of ideas, the invention of the wheel and the telescope and the airplane, without ever needing to change to remain present for any of it. Scientists believe its surface has looked essentially the same for hundreds of millions of years. So the moon that shines tonight is, for all practical purposes, the very same moon that shone over the earliest human ancestors who ever paused to look up. There is something quietly steadying in that thought, that across every century of turmoil and change, of joy and hardship, one calm presence has remained overhead through all of it, asking nothing, judging nothing, simply continuing to shine as it always has. Although it feels perfectly fixed in place, the moon is slowly drifting farther from Earth with every year that passes. Using small reflective panels left behind by Apollo astronauts, scientists bounce laser light off the moon's surface and measure its distance with remarkable precision. And these measurements show it moving outward by about 4 centimeters annually, roughly the thickness of a stack of a few coins. It is a pace so slow that no person could notice it across an entire lifetime, or even across the whole of recorded history. Yet stretched across vast stretches of time, this gentle retreat adds up to something real. Scientists believe that over hundreds of millions of years to come, the moon will appear gradually smaller in the sky, and eventually it will sit too far away for its disk to fully cover the sun, ending total solar eclipses as we know them today. Some have wondered whether, billions of years from now, Earth's day and the moon's orbit might slowly settle into a matched rhythm, though most agree the sun's long life will end long before that quiet point could ever be reached. For now, the drift continues, gentle and steady, a few centimeters at a time. There is something worth sitting within the difference between a single night on Earth and a single night on the moon. Down here, a night might hold 100 small events, a door closing somewhere, a car passing on a distant road, wind moving through trees, a light switching off in a window. Up there, nothing of the kind happens at all. No breeze stirs, no creature moves across the ground, no sound travels anywhere, because there is no air to carry it. The moon simply rests in its slow orbit, unchanged from 1 hour to the next, while an entire world beneath it hurries through its business, its worries, its plans for tomorrow. Scientists studying its ancient, barely eroded surface note that many of its features have remained almost exactly as they are for hundreds of millions of years. A stillness with no equal anywhere on Earth's own restless, weathered ground. Perhaps that contrast is part of why looking up at it can feel so calming, a reminder that not everything must hurry, change, or be rebuilt. Some things are simply allowed to remain calm and unhurried, watching the business of the world go by without needing to join in. Long before streetlights or headlights existed, the moon was one of the most reliable sources of light a traveler on Earth could count on. Sailors crossing open water at night steered by its glow reflected across the waves. Caravans crossing wide deserts moved after sunset by its pale light to escape the heat of the day. And travelers on foot along forest paths or mountain trails often waited for a bright moon before setting out after dark. Unlike a lantern or a fire, it required no fuel, needed no tending, and could be trusted to appear in some form on nearly every night of the month. Even after compasses, maps, and modern instruments took over the technical work of navigation, the moon kept its quieter role as a comfort to anyone moving through darkness, a familiar shape overhead that made an unfamiliar road feel a little less uncertain. Wanderers of every kind, shepherds, messengers on long night rides, fishermen returning late to shore, came to know its light as a kind of company. Even today, with satellites guiding ships and cars alike, many people still find themselves glancing up at a bright moon on a dark road, grateful in some quiet way for the light. On the face of the moon, there is a soft, ever-present line where daylight meets darkness, known to astronomers as the terminator. It marks the boundary between the side currently lit by the sun and the side still resting in lunar night, and rather than a sharp edge, it appears as a gentle, shadowed band where sunlight strikes the ground at a low angle. Because of that low angle, mountains, crater walls, and ridges near the terminator cast long shadows across the ground, making this one of the most striking regions to observe through a telescope, full of contrast and detail that vanishes once the sun climbs higher. The terminator is never still. As the moon moves through its cycle, this line slowly sweeps across the surface, bringing sunrise to one region after another in a journey that takes about 2 weeks to cross from one side to the other. Any single point on the moon experiences this slow crossing only twice each cycle, once as the line brings morning, and once as it returns bringing evening. It is a quiet, unhurried kind of sunrise and sunset, stretched far beyond anything on Earth, moving gently across the gray landscape like the slowest tide imaginable. Long before clocks or calendars existed, the moon offered one of the simplest, most dependable rhythms in nature, a steady cycle of light and shadow repeating roughly every 29.5 days. That gentle repetition became woven into the wider rhythm of life on Earth, echoed in the ebb and flow of tides along every coastline, in the timing of certain sea creatures, in the seasonal habits of animals that sense its changing light, and in generations of human tradition built around its return. It is easy in a world full of artificial schedules and glowing screens to forget that a slower, older kind of timekeeping still continues quietly overhead, indifferent to clocks and unaffected by hurry. The moon does not rush through its phases to meet a deadline, and it never skips a turn. It simply continues, patient and exact, the way it has for longer than any living memory can reach. In its own quiet way, it stands as a gentle reminder that nature keeps its own time, unhurried and cyclical, and that some of the oldest rhythms shaping life on this planet are measured not in hours or days, but in the slow, steady turning of the sky itself. Somewhere on Earth right now, in one of the many hours of night slowly rolling across the planet, the moon is hanging low and pale over rooftops, fields, coastlines, and mountains, shining its same soft, borrowed light as it always has. It rests above sleeping cities and quiet countryside alike, indifferent to borders, unaware of the different languages spoken beneath it, asking nothing of anyone it shines upon. Night makes its way around the turning earth, and in whichever hour it happens to be there, someone, somewhere, is drifting towards sleep beneath its glow, sharing the same quiet companion overhead without ever knowing it. It has watched over sleep long before electric light existed, long before clocks, long before any of the worries that might be drifting through a mind tonight. Steady and unchanged in all the ways that matter, it will still be there tomorrow night, and the night after that, circling faithfully as it always has, asking for nothing in return. For now, it simply shines, quiet and constant, over a resting world, a calm and familiar light keeping watch through the dark, exactly as it has for longer than anyone can remember. As we come to the end of tonight's journey, the moon continues on, exactly as it always has, rising, turning, resting, in that same slow rhythm it kept long before the first human eyes looked up to find it. It will keep its quiet watch over rivers and rooftops, over coastlines, over every sleeping town, long after tonight is forgotten. You do not need to remember a single fact or hold on to anything at all. Just let the silver light settle over you like a soft, warm blanket and let your mind go still. Sleep well, dear friend. The moon is watching over you tonight, gentle and patient, exactly as it always has. Rest now and sleep. QC, chapters equals 10 facts equals 100 words equals 20,467.